Hi, my name is Cassidy Gibson, and I'm from the University of Florida. Today, I'd like to talk to you about how stalkerware apps on mobile devices monetize themselves, specifically on the Android platform. I'm going to do this and talk today about my paper, Analyzing the Monetization Ecosystem of Stalkerware. Thank you for coming. Today, I'd like to introduce you to a term called intimate partner violence, or IPV. You probably heard about this before, also known as domestic partner violence, domestic abuse, but it's abuse between any partners in an intimate relationship, whether this abuse is emotional, physical, or psychological. And this is a global problem. Even countries like Australia and the United States are affected by intimate partner violence cases. In fact, in the United States alone, intimate partner violence accounts for over 15% of all violent crime. Over 1 in 4 women and 1 in 10 men have experienced intimate partner violence. While it's a problem for both genders, the victim count is heavily skewed towards women. And this has only been a growing problem since COVID. In 2020 alone, with the uprise of the pandemic and everyone having to quarantine, we saw a spike of over 25 to 33% across the globe of cases being reported of intimate partner violence. And this is only increased by the ability for tech-enabled abuse. Today, I'd like to introduce you to Stalkerware. It's one type of tech-enabled abuse that allows abusers to remotely access information on the victim's phone and conduct real-time surveillance. It allows them to access the victim's location, view their text messages and social media conversations, listen to phone call recordings, and view their call logs. And in some cases, they're able to access their camera and microphone, allowing them to see live video and voice recordings around the phone happening at that time. This is all done remotely, where the abuser can access it on different types of platforms. So while we obviously know that stalkerware developers are making money in this field, because why else would they be making these apps in the first place, we have very little understanding on how these developers are actually monetizing the apps. Furthermore, companies like Google and Apple have noticed that stalkerware is a problem, and as such are taking steps to stop stalkerware on their platforms and on their mobile devices. Google, in fact, changed their terms of services to effectively disallow stalkerware from all of their platforms. And as such, we want to identify how stalkerware apps are monetized and use the information gained from this to make a recommendation for a holistic approach on how to stop stalkerware from generating revenue. We also want to use this monetization data to then analyze how successful Google's TOS change was to the stalkerware ecosystem. To do this, we needed to analyze or identify different ways that these stalkerware apps monetize themselves. And we identified 3 of these. The first one being in-app ad libraries. This is a passive way of generating money, and it's done through ad revenue. This can be when a user on the phone views the ad, clicks on the ad, or buys something on the website that the ad takes them to. There's also in-app purchases. In a lot of cases, not in stalkerware, these are often seen as microtransactions. But in the case of stalkerware, we see these as purchases of subscriptions or extra permissions on the phone, and we identified them through payment processors that were supported by the app. Finally, we found evidence of external websites. Abusers were able to purchase app subscriptions on these websites, or sometimes they purchased the app and downloaded the app from these external websites themselves. To gain all this data, we needed to have a fairly large repository of stalkerware apps, and the one we finally ended up using was the Stalkerware threat list. This repository is created by members of the Coalition Against Stalkerware. They're an international collaboration between security companies, the National Domestic Abuse Survivors Networks, digital rights advocacy groups, and law enforcement. In fact, we ended up joining the Coalition Against Stalkerware so that we could also help in this problem. We took a snapshot of the STL and looked at the Stalkerware apps that were found between July 14 of 2020 and November 3rd of 2021. We were able to identify 6,439 Android applications in the STL, and then we ran these apps through different decompilers. We originally used JDEX, but we found that 733 of these apps could not be decompiled by it. We did finally use JebPro on those 733. It's known for helping with deobfuscation, and we were then able to decompile another 726. In the end, we were able to decompile overall 6,432 of the Android APKs, missing only 77 of the original 6,439. We found that in both cases of apps being decompiled by JDEX and JebPro, they revealed all of the same markers for monetization data that we were using in our research. So with all these apps and APKs that we had decompiled, we first ran an analysis of ad libraries on them. We found that over 1 in 4 of the apps in the corpus used ad libraries. We found that to be a rather large number. From that number of roughly 1,700 apps, almost 1,500 of them only use a single ad provider in their entire app. They only relied on a single ad provider to generate all of their revenue. And all but 11 of those 1,479 apps used Google AdMobs. This seemed rather drastic. And in fact, it appears that by cutting off Google AdMobs ad services to these Stalkerware apps, we're removing almost 1 in 4 of the apps in the corpus' ability to generate revenue through ad libraries. We also wanted to know, is this behavior unique to Stalkerware, or is this how all apps work with ad libraries? Do they mainly use a single ad library, and do they mainly rely on Google AdMobs? To do this, we decompiled 442 samples of benign, or what we would call benign apps, from the Google Play Store's top 500 app list. We then randomly sampled 250 apps from both our benign group and our malicious group of Stalkerware apps. We found that the behavior of using only a single ad library was mainly a thing for Stalkerware. Stalkerware almost did this 90% of the time. But in the case of normal apps or benign apps, this was under 40%. It was much more common for benign apps to rely on multiple ad libraries at a time to serve their ads, and in some cases relied on up to 22 ad libraries to generate their ad revenue. Furthermore, we found that even when they only relied on a single ad library, it was much less common for them to solely rely on AdMobs. In fact, it was much more common to see see other ad libraries used in a much more higher number. Next, we wanted to look at in-app purchases. We identified payment processors supported by the apps by using keywords. And we created this keyword list by looking at different papers that have been highly looked at and supported in our industry. We use this keyword analysis to identify behaviors of the apps, in fact, as well. Words like subscription obviously gave us an idea that these apps were using a subscription basis. What we call IABS in these graphs refers to in-app billing services. In-app billing services, in fact, can only be used when these apps are currently on the Google Play Store. So this gave us an idea of what versions of the same apps were on the Play Store and what versions of these apps were not. Finally, we looked at payment processors like PayPal, Square, and also credit cards like Visa, Amex, and MasterCard. But we also wanted to see, since these are malicious apps, if it was rather common for cryptocurrency to be used in these apps. And we looked at these between the different versions of their apps, and you can see that different versions did have different behavior in the case of how their payment processors were identified or were being used. And we wanted to compare between these versions of the same app so that we could see how they changed over time. And we finally settled on target SDK versions as a way to view this change over time. We're going to see how these payment processors and behaviors really shifted as different things occurred. While Target SDK version is not a specific or not an exact time period when these apps would have been running, it does give us a good idea on relatively how things changed across a period of time. Finally, with all this data, we wanted to see how the revenue generation changed over time in the ecosystem and how it's affected by different changes like Google's TOS change. As of October 2020, Stalkerware became explicitly prohibited from any of Google's services, including the Play Store and Google Ad Mobs, which we saw be very prevalent in the Stalkerware apps. And they decided to rely heavily on this Google Ad Mobs across these Stalkerware apps. To look closer at this graph, or to look closer at this in our longitudinal study of the TOS change, we identified apps that we knew had to have been on the Play Store at some time. We were able to do this by using the IABS, or in-app billing services, keyword in these apps. We looked at the apps that were identified before the TOS change of October 2020 and after the TOS change of October 2020, and identified that if any of their versions of their apps had used in-app billing services, they had to be on the Play Store at some time. Therefore, using our keywords for behavior, we were able to identify if they had been taken off the billings, if they had been taken off the Google Play Store, as in they stopped using the in-app billing services keyword after October 20, or if they were still on the Play Store, or if they were able to, and to see how this affected the overall monetization change. Overall, the changes vary between keywords. However, you do see a change in these keywords for every single keyword. Before and after the TOS change, we see, in most cases, a drastic drop. Some stay relatively the same, like MasterCard, but we do see that looking at the in-app billing services and even cross-referencing it to the actual Play Store currently, Stalkerware overall has been taken off the Play Store by a large proportion. However, we do see an increase in the subscription keyword, and therefore we know that the use of subscription basis in these apps has increased after the TOS change. As such, we know that it did create some change in the ecosystem. However, from our research, we found that the ecosystem of Stalkerware is largely different from other papers that have been done on looking at the monetization of different types of groups. Levachinsky's in IEEE of 2007 showed that spam relied solely on only 3 different banking systems on their click trajectories paper. But Stalkerware is a much more decentralized system, so we can't default back into what they did to correct this problem. In fact, we instead recommend that attacking the monetization network for Stalkerware needs to be multi-pronged and a collaborative effort between all parties that allow Stalkerware to make their monetization occur. This means better communication between the coalition identifying Stalkerware, the payment processors, and Google's Play Store to all help shut down these apps. Thank you for listening to my talk today. And if you have any questions, I'll now take them. Thank you so much.